Good morning. In today's class, we will learn about one more graph traversal technique, that is depth first search. In the previous class, we have learned about breadth first search. Now in today's class, we will learn a depth first search. The depth first search is a graph traversal algorithm. In this algorithm, one starting vertex is given, and when an adjacent vertex is found, it moves to that adjacent vertex first and try to traverse in the same manner. That is, a depth first search means to search deeper in the graph. In depth first search, each new node is encountered. It is marked to show that the vertex has been visited. The strategy followed in DFS is as follows. That is, a vertex U is picked as a source vertex and is visited. A vertex V adjacent to U is picked and is visited, and search begins at the vertex V. There may still be some nodes which are adjacent to U but not visited. The search continues deeper and deeper in the graph until no vertex is adjacent or all the vertices are visited. Then the search resumes from the last vertex which still has not been visited, and search resumes from this point onwards. This process is repeated till all the nodes are visited. I will take one example and show you how this depth first search is implemented. Now consider for this graph, I'll implement depth first search for this graph. You can choose any vertex as a starting vertex. Here C is chosen as the starting vertex. From C, there are 4 adjacent vertices: C to A, C to G, C to X and C to Z. So if we choose C to A, then from A again there are 2 adjacent vertices, that is W and Q. So you can choose A to W and mark it as visited. And then from W there is one more vertex from W to L. So you can visit W to L. In this way, from the source vertex you are visiting or going deeper into the graph. Rather than choosing the adjacent vertex A to from C to A and A to G, you moved from, that is C to, you selected C to A to W and W to L. Then again we move back to the previous vertex and there are no adjacent vertices here. Again we move back to vertex A. From vertex A there is one unvisited vertex, that is Q. You visit that vertex, mark that vertex as visited, and you move back to the initial vertex C, and from C there is one more unvisited vertex, that is G. Mark it as visited, and from G there are no more vertices to be visited, so move back to vertex C. From C there are again vertices to be searched, so you choose C to X. From X you can go to vertex P. From P you can go to vertex K. From K to W, and again move back to the previous vertex K. From K you can visit R. From R there are no more adjacent vertices, so move back to the previous vertex, and from K again move back to previous vertex P. From P there is one more vertex which is unvisited, so mark it as visited, B. Again move back to vertex P, and from P you move back to there is one more adjacent vertices which is unvisited, so visited, that is Z. And from Z there are no more vertices to be visited, so move back to P, and from P move back to X. From X there is one more unvisited vertex, O, so visit it. Again move back to X. From X there are no more vertices to be visited, so move back to C. From C you have one more unvisited vertex, that is Z. Mark it as visited, and from Z you have one more unvisited vertex, that is U. In this way the depth search is implemented. That is, rather than from first vertex you choose the adjacent vertices, from then you choose another adjacent vertex, and in this way the search goes deeper in the graph. Rather than choosing the adjacent vertices, the search goes deeper in the graph, hence it is called as depth first search. Now, by implementing depth first search, I want to search the vertex or node B in this graph. We will see how it is done. So, I will begin with vertex C. C as the starting vertex. From C, I will choose vertex A. From A, I will go to vertex W. From W, I will go to I will choose the vertex L. From L, there are no more adjacent vertices, so move back to W. From W also there are no more unvisited vertices, so move back to vertex A. From vertex A, there is one unvisited vertex, that is Q. Visit Q, and there are no more vertices to be visited, so move back to vertex C. From C, there is unvisited vertex G. Visit it. Then from G, there are no more vertices to be visited, so go back to C, and from C you have X, visit it. Then you have P, visit it. Then you have K, visit it. Then K to M, visit it. Then back to K, and from K to R. Then there are no more vertices to be visited, so move back to the previous vertices, that is from K to P. From P you have adjacent vertex, that is B, and you have found the vertex B, that is node B you have found it. In this way the depth first search is implemented.